Assalamualaikum and hello everyone. In this video, we are going to look at the concept of pivot position, which is important in solving system of equations. And we also will be going to use this concept a lot in our future lessons. So specifically in this video, we aim to identify pivot position in a matrix and augmented matrix, and also to determine leading and free variables from augmented matrix. Okay, let's start with the matrix A, and we are going to reduce A to its equivalent echelon form using elementary row operations. You may want to pause this video and try to reduce A yourself. Once you're done, you can continue playback to check your answer. First, we interchange row 1 and row 3. Next, we subtract 2 times row 1 from row 2 and subtract 3 times row 1 from row 3. Next, we take row 3, subtract row 2 to obtain the echelon form, and let this matrix be E. We can further reduce this matrix to obtain its reduced echelon form by adding row 3 to row 1. Let this matrix be R. Notice that the leading entries are always in the same position. These fixed positions are called pivot positions, and the columns that contain them are called pivot columns. In this example, column 1 and 2 are pivot columns, and column 3 is a non-pivot column. Next, we consider the following augmented matrix, where the first 3 columns represents the variables x1, x2, and x3. Since column 1 and column 2 are pivot columns, then x1 and x2 are called leading or basic variables. Column 3 is a non-pivot column. Therefore, x3 is called a free variable. In summary, a pivot position in a matrix is a position that after performing ERO contains a leading one. A pivot column is a column containing pivot position. The variables corresponding to pivot column is a leading variable, and the variables corresponding to non-pivot column is a free variable. Hopefully you find this video useful. With that, Assalamualaikum and have a very pleasant day.